Many sewage treatment plants are designed properly, but in operations they fail. We're going to see in a series of discussions, which is also going to be shown as presentation here. And today we will see why many sewage treatments fail in design, and the factor that we are going to consider is peak factor. Let's see what is peak factor. Is peak factor always 2.5 or 3? The answer may be yes or no, or depending on building types. There's no right or wrong answer, but there are contextual answers which fit into why and how and what peak factor should be considered. Now, what is a peak factor? It is the maximum hourly flow divided by the total design flow considered. Let's take an example and see where we are in the later slides. This logic of peak flow of 1.5 to 2.5 is what is considered in most designs, and this is applicable to sewage treatment plants that are built for cities or municipal sewage treatment plants, where a large population is being taken care by the sewage treatment plant, where the sewage flows in open or closed sewers from distances can be 10, 15, 20 kilometers apart, because sewer networks do not straightly drain into the sewage treatment plant, but they are reticulated systems going through many communities and streets and roads. And by the time the water from a house reaches a sewage treatment plant, can be somewhere between 1 hour to 10 hours. There, a low peak factor is applicable because the city is also widespread. The water from the nearest home reaches soon, the farthest home reaches later. Now, when it comes to small decentralized plants, the same peak factor can be applied, but is it the right way to apply is what we are going to talk about here. Let's imagine there is a sewage treatment plant in a building or in a community where the water from the houses reach the sewage treatment plant not in hours but in minutes. And the occupant's behavioral pattern is going to be the most influential thing in deciding what is a peak factor here. It's not the formula of 1.5, 2 or 2.5 that is going to work, but understanding behavioral pattern is what we're going to analyze in the coming slides. Why is sewage flow a behavioral issue and not a flow or a mechanical issue is what we will see now. In a commercial building, peak flow comes from various different factors. One can be the timing at which the people enter the office. Most of the people come to the office, when they enter the office, they're using the toilets, washing their hands, sometimes washing their faces, using toilet because they traveled a long distance without having access to a toilet, and then start work. This has a big influence on peak. Lunch breaks, again, are where there's a lot of usage in toilets and washing of hands and then washing of plates and so on and so forth. There are, again, times when people leave the office, there is going to be a surge of water usage. In certain types of building, there can be other peak intervals during the day. And most commercial buildings are operated not in 24 hours time, but somewhere between 8 to 12 hours time. All this has an influence of how we calculate peak factors. In a residential setup for a decentralized sewage treatment plant, I would like you to imagine a peak factor of 2.5 and can go up to 4. An office with 1 or 2 shifts can be 3 to 5. And the peak factor for a mall can be 4 to 7. We'll go into the details further. Let's take a mall as a case study here. And for the sake of discussion, I've taken a 240 KLD sewage treatment plant in this mall. And let's also assume the mall is operating for 12 hours in a day. And the sewage treatment plant runs for 24 hours in the day. Now, let's take the present approach towards how peak factor is considered. Let's say we've already assumed that it's a 240 KLD plant. Divide by 24 gives 10 kiloliters per hour. Now, when we put a 3 hours of peak factor, the total volume comes to 30,000 liters per hour. This is the usual way of approach from designers. On the other hand, let's apply some behavioral change of peak factor. Now, let's apply our logic of influence of behavior and peak factor. A 240 KLD plant in a building that is operational for 12 hours means 12 hours should be taken as the day. Divide this 240 liter KL by 20, we get 20 kiloliters. Now, applying a peak factor of 3, it gives 60 kiloliters per hour. Or we can even consider a peak factor of 5, which gives 100 kiloliter per hour. You see there is a big difference. In our previous approach, or the approach that is commonly used, the peak flow is 30,000 liters per hour. Whereas with our new approach, it has become 100,000 liters per hour. You see the difference? It's more than 3 times the water that has to be considered into the peak factor calculation for a commercial building. There's more to this. A peak factor of 3 over 12 hours is applicable on a weekday. But think about weekends. Weekends, every mall gets its footfall completely differently. There's more people coming and there are more surges. So the peak factor can go up to 7. So you see the big difference here. These are the reasons why sewage treatment plants fail. They're not failing because of hydraulic reasons alone. They are failing due to peak factor misunderstanding. First, peak factor influences the hydraulic flow, which again influences the biological parameter of the water in the treatment plant. Now let's see what happens to the biological fraction of the treatment plant. Having seen the weekend influence, let's understand something a little deeper. There is a hydraulic failure because of not having understood the right peak factors. This again leads to biological failure in the sewage treatment plant due to various reasons. But there could be many reasons for failure of sewage treatment plant that are designed taking wrong peak flow into design consideration. We'll have this discussion in a later presentation, but let's stick to the hydraulic parameters alone now. The influence of peak in reality is needed for the plumbing design and the pipe diameter and flow pattern design in a building. Then, if there are pumping stations, the pumping station's choice of pump should be decided on the peak factor. Finally, where it affects the sewage treatment plant is in the sizing of the collection or the equalization tank. So, you see, the influence in the sewage treatment plant is only in the equalization tank, whereas the peak has its influence on the sizing of the pipes and also in the sizing of the pumps. Finally, what we have learned here, let's not design using formula, but consider what is the type of building and the behavior pattern of the people that use the building. Having learned something about peak factors, let's ask ourselves a few questions. For a mall, should we design the sewage treatment plant with a weekday peak factor or a weekend peak factor? How do we even measure real peak? And for the next episode, we're going to talk about equalization tank and its role in the treatment. Thanks for now.